Good morning, guys. Am I audible to all of you?
Yes, sir. Good morning, sir.
Okay. My screen is also visible to all of you, right?
Right, sir.
Okay. So basically, yesterday we have started entity framework and we have discussed what entity framework can do for us. And we have created a simple application using edu.net, right? And I have not explained anything about what is the edu entity framework and all these things. So from today onwards, we are going to start entity framework indeed, right? So basically, you can see this is my designer view, right? So what I have created, this is draggable, right? So you can drag and drop anywhere, and it will also work fine, right? So basically, if you are going to work with the edu.net entity framework, then one of the important concept that you need to understand that is context clusters. So let us first try to understand context class, and whatever I'm explaining today, it is not specific to any database approach, any entity framework approach. Like you can consider it is applicable to database first approach, it is applicable to model first approach, it is also applicable to code first approach. So today's session is going to be common for all the different approaches, right? When we start our actual approach, then you will see these things are going to be there, right? So basically, why we are using entity framework? So we are basically using an entity framework to perform the CRUD operation. That means what? Now we need to select some data from the database. We need to update some data into the database. We need to insert some data into the database. We need to delete some data into the database. And how we are going to perform all these things using entity framework means by using a .NET object. We are not going to write any SQL statement to perform the CRUD operation. Using .NET object only, we are going to perform CRUD operation, and this is possible by using .NET entity framework. How? How it is possible? And this is possible by using one of the important concept called the DB context. So this is the possible by using entity framework, and this is possible by using DB context class, right? So the class which is primarily responsible for interacting with the database is DB context class, or you can also call this class as a context class, right? The context class in the entity framework is a class that is derived from a DB context class, right? So what it means, now whenever we create a class by and if that class is inherited from the DB context class, then we can say that class as a context class, and we can use that class, right, to make to interact with the database. That class will represent a session with the database, and within that session we are going to perform the CRUD operation using .NET object, right? So guys, remember one thing, right? So if we are using entity framework means we are not going to deal with a SQL statement. We are only going to deal with the .NET object. What do you mean by .NET object? .NET object means only class and only class. So there is a class, we need to use the object of that class, and using that object, we are going to interact with the database by using the entity framework. And behind the scene, this DB context class is there, and that class will be responsible to interact with the database, and that class will be responsible for converting, right? Whatever statement we have written, those statements are going to be converted into the corresponding database, right? If the corresponding database is Oracle, then it is going to convert those statements into SQL format that the underlying database can understand. If the underlying database is a SQL server, then whatever statement, whatever .NET write code we are going to write, those code are going to be converted into SQL statement, right? That the underlying SQL server database can understand. And same thing in the case of a MySQL. And one more thing, this DB context class belongs to system.data.entity namespace, right? So we have already created one application, right? And this is the structure of your application. And you can see within your ADMX file, there is a TT file. Within the TT file, you can find this entities class. So if someone asks you what is TT file, so TT file means it's a T for template, which is basically used to create your classes, or it is basically used to create your entities based on the database schema, right? So based on the database schema, it is going to create your classes. And you can see in this is the overall structure of an ADMX file. And here department employee, these are .cs file. Here EF demo DB entities, it's a .cs file, right? Employee data model .context.cs. So it's a class file. So these are class files. As these are class files, then entity framework uses this TT file to create this class file, right? Later, if you opted something, right? Yesterday I have shown you, I have modified the EDMX file, right? I have to modify the name of a column, right? Then when I rerun this TT file, those changes are affected here, right? So basically TT file is going to generate the model classes based on the your designer EDMX designer view. To make you understand what I can say, right? So currently this is your EDMX designer view. It is having also XML representation, right? But this is nothing but your entity data model EDMX view, or you can say this is the design view, right? And currently you can see this is my employee class, and inside this employee class, I'm having ID name, email, gender, salary, and department ID, and one department property, right? What is this department property we are going to discuss today, right? So what I'm trying to make you is, so right, so this is salary, right? So I just make this column to salary too, right? So once I make this column to salary too, you can see this star symbol is here, right? You can see this star symbol is here. So that means something changes in the ADMX file. But still, if you go and check, the salary 2 is not yet updated. So how you can update this? Just Control S. Right? So Control S means the ADMX designer is changed. So it is saving the change, and whatever changes you have made, right? Those are going to be affected. Now it is saying the file has been changed externally and has no on-saved changes inside. Do you want to reload it? Yes. Right. So once you reload it, now you can see the salary column is salary, right? So here you might be one question, sir. I have not used the TT file, then how these changes are made affected internally? EDMX file running this TT file, right? Internally, this EDMX file running this TT file to do the changes, right? Now, if you want to make sure, what you can do is, right? So rename. So let me update this one to salary again, right? Now I'm not saving that changes here, right? So what I'm doing, I'm going here and running the run custom tool, right? I'm using this TT file and I run this run custom tool, right? So one it is running, right? Then you will see it is also going to update that employee property, right? So not updated because it has not saved. So first of all, you need to save this one. So this is the until and unless you are not saving, right? Those are not going to be take affected. So first of all, you need to save this, and internally this TT file is going to be generated, right? So I will show you this thing, right? Because currently it is not affecting because internally, because these changes you have made, it is not saved, right? So once it is saved, then it is going to be affected. But behind the scene, this TT file is going to do all these things, right? So any changes that you made in the designer file, those changes are made affected into the CS file only when this TT file is run, right? And this TT file is run when you save the changes, right? When you save the changes internally, it will run this TT file, right? So you can see these are the TT file, and one of the TT file is generating one class called employee data model.context.cs. This is our context class, and this context class is inheriting from the DB context class. Now, if you go to here, right, this is my employee data model dot context.tt, and this is, and if you expand this, then you will see that employee data model dot context.cs. Now, if you go to now if you open this CS file, then first of all, guys, you can see what is this auto-generated. Auto-generated means whenever one file is automatically generated by .NET framework, then you will see this thing auto-generated. And what it is suggest, this code file was generated from a template. What is the template? This TT is nothing but your template. This TT is going to is generate this template, this class file, right? Manual changes to this file may cause unexpected behavior in your application. Manual changes to this file will be overwritten if the code are regenerated, right? So it is suggesting, right? You can do manual changes, but if you are doing manual changes, then the behavior is going to be unexpected. And again, if you are doing manual changes, right? Suppose I'm making this, I'm adding a property here, right? So let me add a property. So what I'm trying, public integer some property, right? I'm adding some property here, right? So I'm adding some property as per my requirement inside this DP context class. Not here. Let me add that inside this employee. This is also generated class. This is also one of the class which is generated by the .NET framework, right? I have added employee ID name gender. Okay, let me add here employee address property, right? I have added the address property, so I have saved that property here. Now what is going to happen, right? So I'm going to the ADMX file, right? I'm doing some changes. I'm making this salary to salary, right? And I'm saving the changes, right? Right. So once you save the changes, go to this file. Where is your added property? That property is removed. That means what? Manual changes to this file will be overridden if the code is regenerated, right? So whenever you are saving this file, right, that means the code is going to be regenerated. And because of the code is regenerated, you can see the manual changes things are going to be overridden. They're going to be lost, right? So do not do any kind of manual changes within this file. Then now you might be one question, sir. If my business requirement saying I need to add few properties into these entities which are generated by entity framework, then how I can do this? Yes, you can do this. First of all, you just check what is the which type of a class is this? Partial class. Then can I create another class file? And in that class file, can I create a class with the same name with partial? Guys,
Means here in this class only.
no, in this, not in this class, right? I want to
Uh,
create a different CS class file. Inside that different CS class file, can I create a class with this name employee and with the keyword partial?
yes.
Yes.
Yes, that is possible because partial means its class definition can split into multiple files. If you want to do some kind of a changes, right? If you want to add few properties inside this employee class, a few methods inside this employee class, right? Then you can create a different class file. And within that class, you can add those additional things. And this is possible because these classes are by default partial, right? So this is the auto-generated code, right? And right. Now, let us try to understand this context. So this class is inherited from the DB context class. Let's go to the definition of a DB context class. What this DB context class saying? A DB context instance represents a combination of unit of work and the repository part, right? So what is unit of work and what is repository patterns? We'll discuss this thing in detail. Don't worry about. So unit of work means what? Now if you want to execute multiple statement, right? So basically you can consider it's a way of implementing a transaction, right? So if you want to implement a transaction, that you can implement repository patterns means what? Now instead I will tell you it's one kind of a design patterns, right? And if you are working with the entity framework, right, then you should know this design pattern. What is this design pattern? I'm not going to talk now. We'll discuss this thing in detail. Again, unit of work also I'm going to discuss in detail. such that it can be used to query from a database and group together changes that will be written back to the store as a unit, right? So that means what? Now using this DB context class, you can query from the database. You can use select query, right? And you can paste the data from the database. Group together changes, right? Group together changes. That means what? That it is also possible that you might have multiple insert, update, delete statement, and you want to execute those statement as a group, and that will be written back to store as a unit. Store in the sense database, and all the right in DML operations, right? It will execute them as a unit, as a single unit. It will execute them in the database, right? If all the operations are successful, then it will be successful, and if any of the operation is failed, then it is failed. DB context is conceptually similar to object context, right? So earlier versions of .NET Entity Framework, there is something called object context, but latest one is DB context, right? If you are using some video Entity Framework version 4.3, right, then you might be saying this object context class. Don't worry, what is currently DB context, that is previously object context, right? So this is the class which is basically responsible for doing all the database related operations, right? So it will make a connection to the database. It will convert our .NET, whatever code we have written, it will convert those code into some TSQL statement so that the underlying database can understand. Then it will execute those TSQL statement in the database. It will retrieve the result. And once it will retrieve the result, it will fill those result with the .NET object, right? And then it will close the connections, right? So everything is going to be managed by this class, right? Then now it might be one question. Now you might be one question, sir. How the DB context class know I need to communicate? It might be possible that your application, right? In this case, your application might be communicating with multiple databases, right? One database in a SQL Server database, right, with the database name as a DB1, another database might be DB2, DB3, like this. Then how Entity Framework will come to know I need to communicate with which database, right? So as from the beginning, I have told you, we need to provide information to the Entity Framework, right? If we are not providing information, then Entity Framework is not going to perform all these things. First of all, we need to give information. And here you can see, so can anybody tell me what is this statement is all about?
Basically, it executes a constructor of DB context class and passing that EF demo DB entities string, like connection string, which
Right.
is available in app.config.
No. See, this is no. Yeah, you are partially right. Right. So basically, this is my constructor of this class. EF demo DB entity. This is my class, and this class is having this constructor. And if you go to the data DB context class, then you will see there is a parameter, right? Name connection string, right? Name or connection string. So what is the name or connection string? Either the database name or a connection string, right? So while calling this DB context class, you need to pass either the database name or you need to pass the connection string, right? So in this case, so this is my child class constructor, and this child class constructor calling the parent class constructor, and this parent class constructor, while calling, it is passing the name parameter value. And this value in this case, is the connection string. How you can say this is the connection string? If you remember, while creating the entity framework, we have provided the connection string name as this one, right? Let me open the document because you will see that things, right? Let me go to the section where we have provided the connection string. Right? So while creating the data model, we have provided save connection settings in app.config as EF demo DB entities. And this is what we are providing to the DB context class constructor app. Now, if you go to the app config, then you will find one connection string, EF demo DB entities. And this connection string, right, what it is representing some employee data model.cshtl. What is CSTL, what is SSTL, right? What is MSL, everything I'm going to cover in detail, right? And then it is providing the SQL client, right? And then it is providing the what is the data source name, right? And then EFDemoDB, this is nothing but your database name, and this is integrated security, multiple reason, and RPG entity framework, right? This is the connection string which is required by entity framework, right? Now to this connection string, I'm providing this thing, and here you need to understand this metadata. What is CSTL, right? What is MSTL and what is SSTL, right? Three things: CSTL, SSTL, and MSL. These three things we will discuss in detail, right? So basically, we need to provide the CSTL, the MSL, and the you can say SSTL. So to give you a brief introduction, what all these things are. So basically, right. So basically, we are having three things. We are having a database. Database means database tables, right? Constant data applied on the tables, right? Then you have a views, you have a storage procedures, etc. In the database, these things are there, right? And in the .NET application, right? So in the .NET application, where it is creating behind the scene classes, right? And functions, right? For a tables, it is going to create classes. Whatever constant is there, those are going to be applicable to the properties. For views, it is going to create classes. For storage procedure, it is going to create functions, right? So that means what? So basically, in the backend database, we are having these things. For .NET application, we are having these things, right? So in this case, if you go to this employee class, so it's a class. If you go to the department class, it's a class, right? And in this class, we are having some properties. In this class, we are in the employee class, we are also having some properties. Then how entity framework will able to know, right? For this particular, this employee class will be mapped with the employee database table. How the entity framework will able to know this ID name, email, gender property are going to be mapped with this ID name, email, gender property of the employees table, right? And for that purpose, right, then we need to provide some mapping information. Entity framework also providing something called mapping. And in that mapping, so he is going to provide the map between the table with the classes, right? Columns with the properties, and storage procedures are going to be mapped with functions, right? So these three things we need to provide to the to whom we need to provide. These three information we need to provide to the entity framework. And how we are going to provide this information to the entity framework means by using this concept called CSDL, SSDL, right? By using this is nothing but your CSTL, right? This is nothing but your SSTL, and this is nothing but your MSL, right? So conceptual schema, data layer, right? Conceptual schema, right? So what is CSTL, what is SSTL, MS we discuss in detail. But in this case, CSTL means it is going to store the information of the backend database, and SSTL means it is going to store the information about your classes and functions. And mapping means MSL means it is going to map the classes and the function with the database. These three things we need to provide to the entity framework, and this information is provided in the connection string itself, right? Now if you want to view, right, sir, I want to view how it is represented, right? All these things, right, whatever it is going to provide, all are going to provide in the form of a XML format, right? And if to give if so if you want to check, right, then what you need to do, right click on this entity framework EDMX file, click open with, and there is an option called XML editor. Just click on that option, right? Once you click on that option, it will show you this thing. And what exactly this? Now the ADMX file you can represent in two ways. One is by using this designer view, and another one is by using the XML view. Already the designer view is open, so you cannot open the XML view. So either one you have to open. Okay, and he is asking, do you want to close this EDMX file so that I can open the XML view? Yes, please close this EDMX and open the XML. Click on the OK button, right? So once you click on the OK button, right, then you will see three information. One is SSTL, another one is CSTL, and another one is CS content mapping. This SSTL, it is going to represent the database, right? This entity type name, it is nothing but a database. This is the primary key column. These are the column of the database table. This is the ID. These are the property, these are the column name of the database table, right? And this association is nothing but your foreign keys, right? Foreign key. If you remember from the employee table, we have created a foreign key which is pointing to the department table. So this is the department table. There is a 0 to 1 relationship. From employee table, it is 1 to many relationship, right? And this is association, and this is container type. Means what are the all the entities available? You can say department and an employee. This is the information of the database, what is going to be used for by entity framework, right? And this CSTL document, it is nothing but your you can say it is the representation of I mean it is the classes and entities, you can say, which are created by the TT file, right? So you should have a department class, you can say department.cs. You should have an employee class, that is employee.cs. In department class, you can have this is the ID is the primary key, ID name, location, and one property called employees, right? You can see there is a property called employees, right? And this is a navigation property. We will discuss what is this. Employee, this is the ID, is the primary key, ID name, email, gender, salary, three, right? Department ID, all these things are there, right? And now you can see this is my department table, this is my employee table, right? This is association, means the foreign key relationship, right? And then this is the container, right? And this mapping is nothing but you can say employee store, data store. So entity state mapping, this is department, means you can say departments. This is the table name, right? So if you remember here, it is creating the entity name as a department. Why? Because in the database, it is departments, right? But in this case, right, while in the CSTL mapping, it is creating the name as a department because the name is a department, right? And why it is possible, why it is creating like this? Because if you remember, while creating the database object, right, while creating the entity framework, we have used one option called singularize and pluralize, right? So let me open that option also, right? Pluralize or singularize generated object names. That what means? It means if the database name is plural, that is started with S, then please make this as singular, right? So this is the reason why in this case database name is employees. So the model name is, sorry, department name is going to be department and employee name is going to be employee. So from this you can say, and another thing that you need to remember, in the case of a database, what data type they are using? They are using database data type, Varchar. This is the data type. This is not the data type of a .NET. This is the data type of SQL Server, integer. This integer is the data type of SQL Server, right? And if you remember employees table, so go to employees table. So what is the data type? Integer, Varchar, 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 right? And the same thing you can see here. And and CSSTL content means in this case the data type is going to be your .NET data type, int32 string. These are the data type of a .NET, right? And in this case, this is the database name and it is mapping. So if you remember what is the department and what is employee model, because if you remember while creating the things, right, we have provided a model namespace. What is the model namespace? Employee model. So what is the class name? Fully qualified type name means the class name before you have to specify the namespace name. So employee data mod, employee model dot department. This is the class name. And in this case, this is nothing but your property name, ID name, location, and this is nothing but your database name. So this mapping information we also need to provide to the entity framework, right? So this is these are the things that is what mentioned here: CSSTL, SSSTL, and MSL. Clear, guys?
Yes.
Yes.
Right? Because why I'm explaining this thing? Because you might be using entity framework, right? Anyone using entity framework earlier?
No.
No. Okay, but see, if it is creating, if it is importing this thing, then we should know what is this CSSDL, what is this SSDL, and what is this MSL. Because in the interview, the interviewer might be asked what do you mean by CSSDL, SSDL, and MSL. You should know, right? And this is the thing, right? Clear?
Yes.
Right?
Yes.
And yeah, so this is the connection string, and this connection string is created in the database, right? And now if you go to the employee context class, then you will see that we are providing the connection string to the db context. And whenever we create an instance of this db context class, right, when we create an instance of this db context class, I mean ef demo db entities, then a session will be established between our .NET application with the database. And how the session is going to be established? By using the db context class. The db context class now came to know that, yes, what is the connection string? This is the connection string I need to use. And from this connection string, he will get the SSTL, CSTL, and MSL information. And then he is going to establish with the database, because apart from this information, also, right, there is the database name, and uh, you can see other thing, right? So you can see this is the database server name, and this is the database name, right? So every information provided to them, and he then going to create establish one session, and within that session we can perform the CRUD operation, right? So this is nothing but your Fluent API, right? We'll discuss what is Fluent API and what is the use of this on model creating, right? So basically it is related to your lazy loading and eager load, right? So lazy loading and eager loading, will cover that concept in detail, so I'm not going to touch right now, right? And guys, whenever you create a class, right, you create this class, you can consider this as a class. You cannot consider this as an entity. And whenever you use this class as a dbset type inside the context class, then you can consider this as an entity, right? So you can see this is employee class. This is department class, right? And this employee class and department class are represented by using the dbset type property. And once you store them as a dbset of type property, then you can say this is one entity and this is one entity, and you can access this entity by using this department properties and employee properties through the instance of this class. Right now, see, now if you create an instance of this employee ef demo db entities dot departments, right, then behind the scene, right, this department entity, right, whatever you specified in the mapping, right, in the MSL, you have specified this department type is mapped with which database, right, table. You specify, then in that case, it is going to fetch the data from the corresponding table, right, departments table, and it will return, and that's it. It is going to return the data of that departments table, and in this case, it is going to return the employee database table data. So you have to specify your entities as a dbset properties, and then only you can access them by using this context class object. Clear? Yes.
Yeah. Yes.
Right.
Yes.
Now this is fine. And one more thing, guys, I need to tell you that. So in the case of a web, if you are developing some kind of a desktop application, then it is going to it is going to store the connection string inside the app config file. And if you are developing some kind of a web applications, right, like if you are developing some web form, if you are developing some MVC, if you are developing some WSAP web API kind of applications, right? Then in that case, it is going to store the connection string in the web config file. So this is the application configuration for desktop applications, and that is web configuration for web application, right? So this is the point that you need to remember, right? Now you understand what is the context class. So you understand what is the context class means. Means if you want to fetch some data from this department table or employee table, first of all, you need to create an instance. Whenever you are creating an instance means this default constructor or zero argument constructor is going to execute. And this default constructor will call the parent class, DB context class, parameterized constructor. When it calls the parent class constructor, that parent class constructor will establish a session with the database, right? And once the session is established, then using this instance, whenever you access, you call this department's property, then it is going to return me the data from the department's table. Why from the department's table? Because in the MSL, right, we have specified this department entity is mapped with the department's database table. So whatever data is there in the department's database table, all those data are going to be retrieved by this department's table. Once the data is retrieved, then entity framework will convert those data into .NET object and will store those data, right? Now, if you go to here, right? So why I'm getting this salary as salary 3, right? Okay. So let's go to here. Let's make this as salary, right? Let's make this as salary. Right? Okay, click yes. So now come to here. Now you just tell me. Now, so DB, and this is my instance. Once this is executed, means the context class object is created. Context class object created means the connection between our .NET application to the database, one session is established, right? Once the session is established with the corresponding database, whenever I access, so this is a property, right? This is a property inside this class, right? So once I access this property, it is going to return me the all the table data, right? All the departments table data, and then I'm converting that to list, and I'm storing those data inside my list of a department entities, right? So once you access this one, right, then for each department, right? So you can see what I'm trying to do here, right? For each department data, I'm again accessing the employees property, right? So if you go to the department class, then you will see there is a property called employees, and here this employees, right? So this property is available inside the department class, and whenever you access this employees property, it will return you the employee table data, right? For each department, how many employees are there, those employee information it is going to retrieve. And this is possible how I'm able to access this employee property only because if you remember, while creating the department and the employees table, I have made this employee table department ID column as a reference to this department's table ID column. That means there is a primary key and foreign key relationship. For that particular primary key ID, how many records are there in the employees table? All those records are going to be retrieved for that particular ID, right? So if ID value is HR, then all the HR employees are going to be retrieved by this department dot employees property, right? But guys, don't remember, but behind the scene, right? Whenever I'm accessing this DB entities dot department, behind the scene, the entity framework is going to generate some select statement. Whenever I'm accessing this statement, right? Behind the scene, entity framework is going to generate some select statement, right? So if you want to see, right, what select statement is going to be generated by the entity framework, then what you need to do, open tool, go to tools, SQL Server Profiler, right? Connect to the SQL Profiler, run this one right now. Now run this application. Right now, you will see that one select statement will be there to retrieve all the department data. And as we have 3 departments, and when this for each loop execute for 3 times, right? So this for each loop will execute 3 times means this statement is going to execute 3 times. That means 3 select statement you will find retrieving the employees table data, right? Let me start. So this is my select statement. Select from departments table, right? That is what I have also mentioning here, right? So this is the select statement which is going to return the department table data. But apart from that select statement, you can see this is another statement, another select statement which is returning the employees table data. And in this case, the department ID is 1. You can see the value is 1, right? You can have another select statement here, employee. It is returning the data from the employee table. What happened? Right, 2. And you can have another select statement. You can see in this case the value is going to be 3. That means what? Now for this statement, it is generating a select statement, and whenever we are accessing the department employees table based on the department ID, it is also generating a select statement right behind the scene. And this information it is creating based on the CSDL, SSDL, and the MCL documents. Right? Clear, guys?
Yes.
Clear, very clear, or still you have anybody having any doubt?
So like I'm just confused, like we have one class which is department.cs, and we have that another class which says employee data model, and inside employee data model we have
Where is employee data model?
uh, so employee data model dot contents.cs.
Where employee data model dot context.cs. This one.
Yes, yeah, this
This
one.
is not your class. This is your context class, right? As I mentioned,
Okay.
this is the context class. In this class, it is not. See, this is your context class. What is the class name?
We have removed DB entities
And here, what is the class name?
department.
So both are different things. So this is your context class. So as I mentioned, the entity framework heart is this context class, right? Context class means we need to provide every information, right? Like this, right? So in this case, right, for example, if I remove this statement, right? If I remove this statement, right, then I cannot perform any kind of operation, right? I cannot see. I remove this statement. Now come to here. Can you access this department property anymore?
No, that is fine, because like you cannot access that property because you already commented out those
Right?
property.
Yeah. So entity framework means, as I mentioned you, who is going to establish the relation, establish the connection with the database?
This DB context class.
This context class. Then what
Yes.
are the properties, right? What are the property you can access using this context class? That means, say, if I'm creating the department table here, if I'm not mentioning that there is an entity called the department, right? Then can you access that entity?
No.
So as I mentioned you earlier, so you can create a department, right? So in this case, we are using what approach? We are using a database first approach. Based on the database, we are creating this department stream. It is also possible that you can use code first approach, where you have to create the code first. Based on the code, you want to access the data from the database. So suppose you created one class called student address, right? And if you want to make that student address as an entity, right, then what you need to do, you need to put that student address as a DB set inside this context class. Then only it is going to access the data from the database and put the data, right? So no matter, so in this case, I can create any number of classes, no matter what. All the classes are not going to be accessed by this entity framework. Whatever class you mentioned as a DB set type, those are going to be become one entity. And right, and once you have to specify those classes, right, which mapping information should be there in the MSL file,
So
right?
like
Then
yeah.
only, yeah, tell me.
So here you said like on line number 28, like we can, whenever we are fetching data, we are getting the data into this department property, right? So
No,
this
you are going in the wrong direction, right? So whenever I'm fetching the data, before fetching the data, entity framework should know now this department table is corresponding with which database,
Mhm.
right? So if I'm
Yes,
accessing department, then he should have idea this if I'm accessing department, then from which database table I need to fetch the data.
from department table.
Then how he will know, okay, I'm going to fetch the data from the departments table.
There is a like configuration file. You said like CD, SL, and
But
MSL.
but how in that configuration file there are many configuration.
Mhm.
Then how you will know? Because of this department. So if you specify DB set of department, then he will check what is the name of this entity department. Is there any mapping configuration provided in the mapping file? Yes, mapping configuration is provided. It is mapped with which database table? It is mapped with the department's database table. Okay, department's database. Okay, let me paste the data from the department's table.
Okay. Okay. So he's here DB set, and the DB set department is there like a data type, right? Like an integer
Yes,
string.
obviously, this is the data type. See how you are creating the properties, right? If I'm
Mhm.
creating a property called like this, some property, then this is nothing but your property, na?
Mhm.
So what is here integer?
Yes, integer is a data type.
Similarly, what is this? This is a data type, DB set of a T type. This is said
Oh, okay.
DB set of T type, and this DB
T.
set of T type, what exactly this is saying? A data set represents the collection of all entities in the context, right? So
Oh, okay.
how many entities are there in the data or in your application? Those entities should be represented inside the DB set,
I see.
right? So in this case, you can see this is one entity, this is one entity. Any number of entity you want to create, right? You have all those entity information should be provided to this division,
Okay, got it.
right? Got it?
Yeah,
So
thank you.
any more question from anyone else? Because these are the basic things, right? And you should know before starting, right? Writing the CRUD operation is not a big deal, right? We can write the CRUD operation, we can perform the batch operation, bulk operation, right? Everything very easy, but understanding the concept is very important. Because why I'm saying this, people are using entity framework, but they do not know what is CSTL, what is SSTL, what is MSL, right? They do not know what is the use of this parameter, right? They do not know what is this on model creating method. They do not know why they are why entity framework creating this. They do not know how entity framework mapping all these things, right? So if you are learning something interesting, right, from the architecture point of view, you should know the line by line. So what is the use of that statement? I will tell you what is the use of a virtual, right? Again, I will tell you what is POCO, what is dynamic proxy, right? Everything I'm going to show you in detail, right? But for now, is that clear?
Yes, yes. And at the starting of class, you had said like 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 when we're using ADO.NET, then we are using that SQL statement, SQL syntax. But here in Entity Framework, we are not going to use those SQL statements. So like we can write any kind of like a complex query, not in sense of query, but like we can write anything so we can get the data from SQL, like
Exactly,
joins and.
exactly. That is the reason why we are going to learn LinQ,
Oh, okay.
right? You know LinQ is there,
Yes, yes, yes.
right? Using LinQ, you can perform group join, you can perform join, you can perform set operation, aggregate operations, right? You can use filtering, right? Everything you can perform using LinQ. So this is the reason why if you are using entity framework means the next concept that you are going to learn should be LinQ. Without LinQ, entity framework is not.
Got it.
Got
Sir,
it? Yeah.
sir, where we can use here stored procedure?
Again, I will show you now. Don't worry. Everything I'm going to show
Okay,
you.
okay.
How to use storage procedure, how to use views, right? Everything
Okay.
I'm going to explain you. Don't worry. Keep patience, right? It's not possible in day one. I will explain everything. right?
Yeah,
But
yeah.
that is already in the pipeline, and I'm not going to explain this entity framework concept using simple example, right? I will take one real-time example to explain this concept. Real-time example means I'm going to explain this concept by using these tables. Standard student, teacher, student address, course, student address, right? These are the 6 tables, right? Apart from that 6 table, right? I'm going to create some storage procedure, right? How to use storage procedure, right? Everything, right? I'm going to explain all these things in detail. But before going into the main concept, right? We should know first of all some of the basic concept, right?
Okay,
This
okay,
basic
okay.
concept are common for all the different flavors, right? We have 3 different flavors, right? This context class, this CSTL, MSL, right? SSTL are going to be common, right? First of all, we need to learn the common things, then we will go into depth of each of these concepts, right?
Right, sir.
And then what is this DB context class is exactly doing? The DB context class is one of the important classes in entity framework. It is a bridge between your domain or entity classes and the underlying data, right? So you can say if you go to this is my domain class, right? Entity, and there is something called a database. That means this DB context class is a bridge between our domain classes and the corresponding database. So it is responsible for performing all kind of database operations, right? For example, you can see this is my domain classes, this is my database, and this is the database. It is used for querying. Querying means what? Now it will convert the link queue to entity queries to SQL queries, right? So as I have mentioned you, right? So in this case, you can see here we are writing the link queue to entities. So here we are writing link queue to entity. Link queue to entity in the sense, here I can also write some kind of a filter condition, right? Suppose if you want, then you can type where EMP such that EMP, not EMP, here department, here TEPT such that TEPT dot ID equals to 1. So I can apply this filter here, right? That means this is nothing but your link queue to entities. You are writing a link queue query using the data, using the entities, model classes, right? So what this querying means, it will convert the link queue to entity queries to SQL queries and send those queries to the database for execution, right? So in this case, whenever I'm writing some statement, right, it is executing these queries, right? So, right, so these are the queries, right? So it will, based on your link queue statement or entities, right? It will generate the SQL and then it will send those SQL to the server, database server, execute those query and retrieve the result. So this is one of the important change tracking, right? So change tracking means what? The DB context class also keep tracks of the changes that had occurred on entities after querying from the database, right? For example, here you have retrieved all the department. After retrieving all the department, did you modify any of the department? Did you delete any of the department? Did you add a new department into this department collection, right? All this information are going to be tracked by the DB context class. And later, based on the state, right, whether you added, modified, changed, or unchanged, right, it is going to perform, it is going to do the respective operations, right? That means whatever happening with the database, right, whatever happening with the entity, right, it is also going to keep track of them, right? So then persisting data. Using this DB context class, right, you can also perform the insert, update, and the database operation, which will modify the database tables, right? So you can also do the insert, update, and delete operation, caching, right? Caching means it is going to store the data in memory, right? And in our coming session, we'll discuss this concept in detail, what is caching. And I hope you guys, most of the guys know what is caching. Caching means retrieve the data from the database and store the data in your .NET application. If you record the same data again and again, then instead of going to the database and fetching the data, right, instead of performing that round trip, right, you can return the data from the cache memory itself. Transaction means what? That from the beginning, I have told you one thing. One is unit of work and repository part. So using this unit of work, we can implement the transactions. Transaction means what? Now, if we want to execute multiple DML statement, right, inside of that statement as a single unit, then we can also implement that in using entity framework, and that is also provided. This support is also provided by this DB context class, right? And the object materialization, what it means, it is also used to convert the raw data which is retrieved from the database into entity object, right? So in this case, whenever I'm executing this statement, it is retrieving the data in tabular format. Raw data it is retrieving from the database, but again, it is converting that raw data into your .NET entities or not. That this functionality is also provided by the entity, provided by the context class, right? So if someone asks you why we should use, what is the responsibility of a context class, this apart from the making a connection with the database, right? These are the functionality that you can perform on using the context. Clear, guys?
Yes.
Right? So these are the things we are going to discuss in detail. Everything I'm going to discuss, pouring, change tracking, proceeding, caching, transaction, manage relationship. Yeah, you can see there is a term manage relationship, right? This class is also responsible for managing the relationship between the entities using CSTL, MSL, and SSL in DB first and model first approach, right? So if you are using database first approach or model first approach, right, then DB context class manage the relationship between the entities and the database table by using these three things. We have already discussed these three things, right? But if you are using a code first approach, then in that case, Fluent API will come into the picture, and that Fluent API is nothing but what I have shown you. This is right. So basically, we are having these options, right? So we can manage these things. Clear, guys?
Yes.
Okay. So this is all about your context class. Next one is entities, right? Few small concepts. Let us try to cover up those today, right? So, right. So if you remember, right? So this is our ADMX file we have already created. And if you go to the definition, right, of this DB context class, then you will see that there are two entities. These are right entities in the sense I have mentioned you earlier. If you are creating a class only, this is not an entity. Entity means what? It should map with a database table. And it is mapped only when you are putting that class as a DB set type inside your context class. That means now I am putting the department class and employee class inside this DB context class, right? So I can say these are two entities of my DB context class, right? So this is what I'm showing here. As you can see, department's property type is DB set of department, and employee property type is DB set of employee. So here department and employee are nothing but entities. An entity in entity framework is a class that is included as a DB set of T entity type property in the derived context class. So this is your derived context class or not? This class is derived from the DB context class, so this is your derived DB context class. So inside this derived DB context class, if you put on the class using DB set of T entity type property, then you can consider that as a entity. So, but technically, if you are speaking an entity in entity framework, is nothing but it's a class, right? And only you can consider that class as an entity when you put that class, right, as a DB set of T entity type within your derived context class. Right? In our example, department entity is mapped to the department's database table, and employee entity is mapped with the employee's database table. These two entities are generated automatically by entity framework, and you can find these two entities here, right? So these are the two entities, right? This is my department entity, and here you can see this is my department entity. And if you look at the database table, this entity having three properties: ID, name, location, and name, right? ID, name, and the location, right? And based on the data type, okay, let's have a look. So ID is integer, this is varchar and varchar. These are database data type. And while creating this entity, it is making this integer, string and string, means these are .NET data type. And then you can see it is having one constructor. What is the use of this constructor means? If you remember, there is a primary key and foreign key relationship between the employees table. This employee table, this is the foreign key, right? So while creating an instance of this department table, so right, instance means you need to create an instance of a particular department. Let's assume the ID1 instance we are creating. Then at that time, what are the related employees? That information is going to be stored inside this employees property. And this employee property is going to be initialized by using the hash table of this department class constructor, right? So here you can see one department having many employees, many means it's going to be a collection. So in this case, it is representing that as a I collection type. So I collection means it's a collection. So whenever you want to implement a one-to-many relationship, that many is going to be represented by using this I collection type. So in this case, this is one-to-many relationship. But now you just tell me, for a particular employee, how many department he belongs to? One department. That means from this employee table, if I want to fetch the department's data, then in that case, this employees table having a property of a department type, that property is going to be a collection or normal property? Normal property, right? If our understanding is fine, then let's go to the employee entity. And is this a normal property or it's a collection property? It's a normal property. Why? Because one employee cannot simply belongs to multiple departments, right? The way we have implemented, create the parent, I mean the department and employee table relationship, one department having many employees, but one employee belongs to a particular department. That's why you can see one employee, a particular department. That information you can fetch here. And here, one department, they are having multiple employees. So you can access them by using this employees collection, right? So department entity, this is the department class, and this is the employee class, right? So department employee, right? So we have, right, department employee are entity. So in this case, we understand that this is an entity and this is one an entity. Why we are saying these are entities? Because they are implemented as a division of a T entity inside our context class, right? Now we are having
Can I have a question, please?
Yes.
Suppose you have tags, right? Like tags. You have one department per employee, but you have many tags. That would be one tag could have many employees, and one employee could have many tags. That would be a multiple. You can map that as well here.
See, what I'm saying, I'm just explaining you the basic concept, right? So the example, what actually we are going to start, in that example, I'm going to show you one-to-many, one-to-one, many-to-many, all the relationship, right? That is what in the next chapter I'm going to discuss, right? But for now, I'm just giving you the basic information, right? So see, in your database, whatever relationship you want, you can implement. You can implement one-to-many, you can implement many-to-many, you can implement many to one, you can implement one to one, right? Every relationship you can implement in the database, and accordingly he is going to create the database tables, right? So don't worry, that is also what we are going to cover as part of this course syllabus, right? So any kind of a relationship you want, you can implement, right? One to many to many, or one to one. This three kind of a relationship you can implement. Clear?
Okay, thanks.
Right? Everything I am going to cover, don't worry, keep essence, right? Because this is the starting, right? So the department and employees are entity. Why we are saying them as entity? Because they are implemented as division of T entity type in the context class. An entity can include two types of properties. What are the properties? One is scalar property, another one is a navigation property. So what is scalar property and navigation property? Let us try to understand. So the scalar property means the property which holds the actual value or the database column value. In this case, in my database, ID name and location inside the department table. In this case, right, in my department table, ID name, location, these are the column which is going to hold the actual department table data, and these are nothing but your scalar property. Scalar means they are going to hold a single value, right? And coming to this employee table, these are nothing but my scalar property. They are going to hold the actual database table data. So scalar means this is right. So now if you go, the primitive type properties defined a class are called scalar properties. So in this case, this is integer, string, right? Integer. These are nothing but your primitive data type, right? They are going to hold a single value, and this is the reason why they are said to be a scalar property. So you can see these in the employee table, these are the scalar property. In the department table, these are the scalar property. The navigation property. So navigation property means, right, represents a relationship with an entity, right? So navigation property means if you are making the primary key and foreign key relationship between the entities, right, then only the navigation properties will come into the picture, right? Suppose you just remove this thing, right? While creating the employees table, you just comment this thing, right? Once you comment this statement, right, then what will happen? Now then there will not be any navigation property. There is no relation now between the department and employee table. If there is no relation, then the navigation property will not come into the picture. Trying to understand, right? Navigation property only come into the picture when there is a relationship between two entities, between two database tables. And in this case, this department table and employee table having the relationship. What relationship? Primary key and foreign key relationship. This is the primary key column, and this is the foreign key column, which is pointing to this ID column of the department table. Now there is a relationship, means navigation property will come into the picture. And again, there are two types of a navigation property. One is a reference navigation property and one is collection navigation property, right? What do we mean by reference navigation property and what do we mean by collection navigation property? Means if it is representing one to many relationship, right? If it is representing one to many relationship, then it is going to be a I mean, it is going to be a collection navigation property. And if it is one to one, right, then it is going to be a reference navigation property. So in this case, this department table having one navigation property, and we can say that navigation property as a collection navigation property because it represents one to many relationship. Because one department having many employees, and that relationship we can say here is collection and navigation property. See, if an entity include a property of another entity, then it is called a reference navigation. Okay, this is the second time. If an entity includes a property of a collection type, so in this case, this is an entity department, it include a property of a collection type, right? Then it is called collection navigation property. It represents the multiplicity of many stars. That is represents one to many relationship, right? For example, in this case, this is nothing but your collection navigation property. It represents one to many relationship, right? Now coming to the other class, right? So other class means other navigational property, right? What is that? Reference navigation property. If an entity includes a property of another entity type, then it is called reference navigation property, right? In this case, this is one employee. It includes a property of another entity. Employee is an entity, department is also entity, and this employee entity include a property of another entity type, means this is going to be your reference navigational property. And reference navigational property represents the one-to-one relationship. That is what it represents, one-to-one relationship between the entities, and the example is this one, right? So these are nothing but your entity. Entity means, first of all, it should be included inside this DB context class as a DB set of D type. Once it is included, then it will become one entity, and within entity we can define two types of properties. One is scalar property, they are going to hold a single value, or you can say they are going to hold the actual database column value, and another property is a navigation property. And again, navigation property is divided into two types. One is a reference navigational property and another is collection navigational property. If an entity store a property of another entity type, then it is said to be a reference navigational property. And if an entity stored a collection of another entity type, right, then it is said to be a collection navigation property. Clear, guys?
Instead of I collection, can we use here also I list or list?
No. So it's
Only collection.
Only collection, I collection, right? So you have to make this as I collection. Define methods to manage generic collection, right? You cannot make it I list or list nothing. Only I. This is the syntax, right? They have provided. You have to use only I collection.
Okay.
Right? If you change this to I list and when you regenerate the code, again it is converted to I collection. Any more question from anyone?
Nope.
Okay, so this is all about entities. Further, once we proceed, then we are going to use this context class, this entities in each and every session, right? So the next one is type of entities, right? So we have discussed entity, right? Then we need to discuss what are the different types of entity, right? So anybody having any idea what exactly POCO? If you learn in Java, they are saying that POJO, plain old Java objects, right? In .NET, we are saying POCO, plain old CLR objects, right? Plain old CLR objects, right? So, and we are having two types of entities, right? So these are not that important, but it is good to know what are exactly these things. POCO entities and dynamic proxy entities. What is POCO? POCO stands for plain old scalar object, which can be used as an existing domain object with your data model, right? So you can use an existing data model, right? You can create a class as a POCO class, right? So POCO, in the sense, if it is understand, if it's a .NET class or .NET object means it's a POCO object, right? So there is nothing more to learn. And what is a POCO? So POCO means this is nothing but you created one class, you can set this class as a POCO. POCO means plain old scalar object, right? A POCO entity is a class that does not depend on any framework specific base class. So in this case, you can consider this class does not depend on any framework specific base class. So there is no built-in framework class is inherited to this class. It's a simple class, right? There is no link between the framework specific class. So in this case, if you go to this example, right, this is not a POCO class because it's depending upon the framework specific class. But if you come to this class, so it's a POCO class because it is not depending on the framework class. It is not depending on the framework class. So these are nothing but your POCO classes, right? So POCO means it's a very simple class, right? And then what is dynamic proxy, right? So now you will understand why it is making this property as I collection, why it is not creating this employee as I list. And there is a reason. And what is the reason that we will understand. When creating instances of a POCO entity, the entity framework often creates instances of a dynamically generated derived type that acts as a proxy for the entity, right? So now if you create an instance of this department class, then the type is going to be the namespace and the class name, the fully qualified name. If you are creating an instance of this department class, instead of a ef demo.department, it gives you a different type, right? It gives you a different type. Then you can say this is not a POCO class. This is a dynamic proxy class, right? Dynamic proxy entity. Behind the scene, the entity is going to be, the type is going to be department, but you cannot see. Proxy means what? You know what is proxy. You know this things very well in your college time. One of your friend is not coming to the college. On behalf of your friend, you are proxying the, right? So you are saying hello sir, yes sir, like this, right? So means what? You are just saying instead of the original, you are saying something. So in this case, so the same thing is also happening, right? If you are creating an instance And if it gives you the type as EF demo.department, that means this is the original type. Instead of EF demo.department, if it is giving you a different type, right? It is giving a framework, .NET framework based class derived type, right? Then it's not a POCO, it's a dynamic proxy type, right? We will say this thing practically, right? So exactly, it can also be said that a runtime proxy class, right? So basically it's a wrapper about the POCO class, right? So in this case, the actual type is going to be this one, but it is wrapped over a different type, right? So that wrapped type information, it is going to give you not the actual type information, but the actual type, the actual instance is going to be this one, right? Then how we can say, right, a POCO is a dynamic proxy, right? The dynamic proxy is a runtime proxy. That class wraps the POCO entity, right? Means it's a wrapper over the POCO class. A POCO entity should meet the following requirements to become a POCO proxy entity, right? So the POCO class must be declared with public access specifier. Now come to this department or employee, whatever class. Is this declared with public access specifier? All the type are public? Yes or no?
Yes.
Yes.
Right. That means the first condition is satisfied.
Yes.
POCO class must not be sealed. POCO class must not be abstract. Are we declaring this class as sealed and abstract? Any method is declared as sealed, any or the class is declared as sealed or the class is declared as abstract.
No.
No.
That means the second and third rules is also satisfied.
Yes.
Yes.
Each navigation property must be declared as public and virtual. In this case, this is one navigation property. Is that declared with virtual and public?
Yes.
Yes.
And in this case, this is another navigational property. Is that also declared with public and virtual?
Yes.
Yes.
Right. That means this condition is also satisfied, right? All the collection properties must be I collection of T type, right? If you want, and why? Because they are actually, whenever the entities are generated, they are wrapping, right? They are generated as a dynamic proxy, right? And this is the reason why you can see the type of Navic collection properties are going to be I collection, right? So in this case, you can see the type is I collection because it is using the dynamic entity proxy entities, and this is the reason why it is marking the class as I collection, right? So the collection property is of type I collection. This condition is also satisfied,
Yes.
right? And the proxy creation enabled option must not be false. Default is true, right? So if you go to the entity framework, right, the proxy creation option is not defined here. How to define, how to make that I will show you. But now we have not defined this proxy creation option, right? Enabled to it's not defined in the context class. So by default, it is true, right? That should be true. And if all these things are satisfied, then we can say that is a dynamic proxy entity, right? The following POCO entity meets all the above requirements to become a dynamic entity, right? Now let me show you this thing with one example. Sorry, not this one. This is my program now. Give me 1 minute, guys. Right. So guys, here you can see I'm using DB entities, I'm using employees, and I'm using the find method, right? So in this case, it is going to return me one employee instance, right? It is going to return me one employee instance. And if you want to check what is the type of that instance, then you just simply to provide the name, right? So in this case, you can see I'm using the find method. Can anybody tell me what is the use of this find method? And what I'm
Find by
passing?
primary key.
Exactly. If you remember, while we are, let me open that entity, right? So open with XML editor, right? So you can see for department, I'm specifying the key. So this is nothing but your primary key. This is nothing but your primary key. So whenever we are passing some value to the find method, so that value is nothing but your primary key column value. And based on that value from this employees database table, right, it is going to return me that particular employee data, and that employee data is going to store here, right? So in this case, right, in this case, I'm using the employee entity, and employee entity, as per our understanding, right, it is satisfy all the requirements to become a dynamic proxy entity. So in this case, right, so it is going to return me an object of employee type. But if you check here, right, that type, it is going to give me something like this. It is not going to give me the type efdemo.employee. Rather, it is going to give me system.data.entity.dynamic-proxy.employee. Why? Because it meets all the requirement to become a dynamic entity type, right? Dynamic proxy entity. And that dynamic proxy entity instance, it is going to return, right? But if you want to know the actual type, right, then you can also use the object context dot get object type, and to this method you need to provide the employee object dot get type, and from this type you can see wrapped type by dynamic proxy, what is the full name, what is the name. Right now, let me run this application. Right, so what is the type it is returning? Dynamic proxy, right? System.data.entity.employee slash some string hard-coded value, it is wrapping, right? That means this is a dynamic proxy. Each time you run, you will get a different value, right? Wrapped type by dynamic proxy. What is the type this dynamic proxy wrapped? It is wrapped the efdemo.employee, right? So what is the fully qualified name of this class? efdemo.employee, right? And if you want to get the actual type, you can get also efdemo.employee, right? The full name, and only name you want to know what is the class name, then you can access that by using the class name property, using the name property, right? Name of the employee master type, full name of the employee type, wrapped type by dynamic proxy is this one, and this is your dynamic proxy. Clear?
Yes.
Right? Right, this is internally used by .NET framework, but it is good to know, right? Then now you might do one question, sir, how we can disable this dynamic proxy? I don't want to use dynamic proxy. Then how you can? By default, the dynamic proxy is enabled for every entity in the derived context, right? So every entity you created, by default, the dynamic proxy is enabled, right? However, we can disable the dynamic proxy creation in the context class by setting proxy creation enabled property to false. So what is this property? Let me show you this thing. It gets or sets a value indicating whether or not the framework will create instance of a dynamically generated proxy classes whenever it creates an instance of an entity type. So whenever it is going to create an instance of an entity type, whether it is going to generate a dynamic proxy or it is going to generate the actual type, that is going to be defined by this property. If its value is set to true, then it is going to generate a dynamic proxy. If its value is set to false, then in that case, right, it is going to create the instance of actual type. To disable dynamic proxy creation, right, so what you need to do, you need to type this statement, right? You need to write this statement, right? So what I'm going to do, okay, now you just tell me where I need to write. So whichever block is going to execute it first. In this case, if I'm creating an instance of this class, which one is going to execute? First of all, the constructor of a
DB
DB
context.
context.
Yes.
Then this constructor is going to execute, right?
Yes.
But can we modify the DB context class constructor? Is the source code is available to us?
No.
This is a framework class. We cannot modify this constructor body, right? Then where I can put that statement, you can put that statement here, right? This dot configuration dot proxy enabled creation equals to false. So what is this configuration class? right? So this configuration property will store all the configuration that is required for this DB context class, right? If you go to the property of this one, so what is DB context? Provide access to configuration option for the context, right? And DB context configuration, go to the definition, what it is saying, written by the configuration method of the DB context to provide access to configuration option for the context, right? For this context object, what are the configuration option, right? You need to provide that, you need to provide by using this class, right? By using this property, right? You can see lazy loading, proxy creation enabled, right? Like this auto detected changes, right? Everything we are going to discuss one by one, right? So if you want to provide any configuration that the context class should follow, then you need to provide that configuration by using this configuration. And here I'm providing this configuration property as false. As I'm providing this property as false, right? That means now the proxy creation is disabled, right? Once the proxy creation is disabled, then in this type, right? Once you create an instance, right? Once the framework create an instance, then that instance is not going to be this type, right? Now the instance is not going to be this type. Now the instance is going to be what is efdemo.employee type, employee type, right? Let me run this application and see whether it is creating the efdemo.employee or not. Right now it is showing the type as efdemo.employee, or it is showing that system.entity.that dynamic proxy. Understand?
Yes.
Right now one more thing let's do. Okay, so let me comment this one, right? By default it is true, and you can also make this property as a, right? Let me comment this one, go to employee class, let me delete this virtual property, right? So if I delete this virtual property, is this POCO entity now satisfy all the requirements to become a dynamic entity, dynamic proxy? Guys,
No, because I guess there is a
see what is saying, each navigation property must be declared as virtual, public and virtual, right? So in this case, this is a navigation property. Is that property declared as virtual?
No.
If it is not declared as virtual, then in this case, is it a dynamic? Give me 1 minute, guys. So now is it a dynamic proxy or it's a POCO entity?
POCO entity.
So that means now if I run the application, even though proxy enabled is true, it is going to show me the appropriate type, not the dynamic proxy entity. Clear?
Yes.
Right? Now you might have one question. Why when to use dynamic proxy? Right? So if you want to use lazy loading or change tracking, then you need to use dynamic proxy. So what is lazy loading? So in our upcoming session, we'll discuss in detail what is lazy loading, what is eager loading, right? So lazy loading means on demand, right? Lazy loading is the default behavior of entity framework. It means the related entity or child entities are loaded only when it is being accessed for the first time, right? So from starting, it is not going to load all the related entities. Whenever you are accessing for the first time, at that time, only the child entities are going to be loaded. And if you want to implement lazy loading in your .NET application, you need to use dynamic proxies. And if you want to use dynamic proxies, then this proxy creation enabled should set to true. Another one is change tracking. Entity framework supports automatic change tracking for the loaded entities. Right? So change tracking means what? Now, if you are accessing some data, right? If you are accessing some data and you are modifying the data, you are accessing some table data, you are updating the data, you are deleting the data, right? And if you want that context class to track all these changes, right, then you need to enable this dynamic proxies, right? So This is the reason why you should understand, you should know what is this dynamic proxy. Yes, it's going further. We'll discuss what is lazy loading, what is change tracking, everything we are going to discuss in detail. But for now, you should know why you should use dynamic proxy in entity framework. Because of the two reasons, one is lazy loading and another one is change tracking. Clear?
Yes.
Any question from anyone?
No.
So basically, how many type of entities? We are having two type of entities. So by default, every entity is POCO entity, and if it is not inherited from any framework derived class, right? If it is inherited from the framework derived class, then it is not a POCO entity. But sometimes the POCO entity can become a dynamic proxy entity. In that case, it has to follow some condition. If all the conditions are satisfied, then it will become a POCO entity, a dynamic proxy entity. And what are the conditions? These are the conditions, right? So this condition must be met to become a dynamic proxy. Clear, guys?
Yes.
Okay. So next one is entity states, right? So entity state means one, as I mentioned earlier. So entity framework, right, automatically track the changes, right? The context class automatically track the changes. That is, change tracking is by default enabled in entity framework, right? So based on the current state of the entity, it is going to generate the insert, update, or delete statement, right? So the entity lifecycle in the entity framework describes the process in which entity is created, added, modified, and deleted. So what is the entity lifecycle? Entity lifecycle means it is going to decide when the entity is created, when it is added, when element are added, when element are modified, when deleted, all these things, right? So entities have many states during its lifetime, right? One entity might be in the created state, added state, modified state, deleted state, right? That means during its lifetime, the entity in a different states. So entity framework maintains the state of each entity during its lifetime. Each entity has a state based on the operation performed on it, right? So if you are performing some adder, if you have added some element, the state is going to be in added state. If you have added some, if you have deleted some statement, right, then the state is going to be deleted. If you are updated some column value, then this is going to be modified statement, right? If you do not want to track the, if you do not want entity framework to track the changes, then that entity is going to be in detached state. And once you retrieve the data from the database, by default, it is going to be in unchanged state, right? So that means the entity state represents the state of an entity, and we are having five different states. So what is added? The entity is marked as added. The entity is being tracked by the context, but does not yet exist in the database. So what it means, once you create the context class, you have added one entity, but this entity is marked as added, but this entity is not saved in the database. It is in memory, but it is being marked as added, but it is not saved in the database. When it is saved into the database, then the change will be changed, the state of this entity will be changed to unchanged, right? And how it is going to save in the database? There is a method called save changes, and once we call that method, then that entity is going to be added into the database table, and then that state is going to be changed to unchanged state. Deleted means if you delete one entity, right, then that entity state is going to be deleted, and again the this deleted entity is going to be tracked by the context object, right? And a deleted state means what? Now the entity is deleted state means it is not deleted from the database, it is deleted in memory. And when you call this save changes method, right, then that that element is going to be deleted from the database, and then again its state is going to be detached, because deleted means you cannot again modify or do anything with the state, right? So modified means, again, if you modify something, unchanged means the entity has not been changed, right? You are paste the data and you have not do any kind of, right? And then detached means the entity is not being tracked by the context. If you call this, if you make an entity as a detached, then it is not going to track by the entity framework, right? The context object not only holds the reference to all the entity objects as soon as retrieved from the database, but also keep track of entity states and maintain modification made to the properties of the entity, right? This is nothing but your change tracking. So as I mentioned, one of the concept of entity framework is change tracking. What it means once you retrieve the data from the database and stored inside the entities, right, then entity framework not only make a reference to the object, right, but also it track what are the things happening with the entity, whether the entity being added, whether the entity being deleted, modified, unchanged, right, whatever happening with the entity, right, everything is going to be tracked by the context class until and unless you have not detached that entity. Once you detached means that entity is not going to be tracked by the entity framework anymore. Everything we are going to discuss with one example. Entity lifecycle. You can see if you have created an entity, right, if it is not a state detached, right, if it is not detached, right, then if the entity is added, then it is going to perform the insert operation. If the entity state is modified, then it is going to generate the update query. If the entity state is deleted, then it is going to perform the delete operation, right? And unchanged means nothing is going to happen on the database. And whenever you modify the added state, right, whenever the entity state is modified, right, added, modified, deleted, these things, right, the insert, update, delete query are going to be only generate and execute on the database when you call the save changes method. For unchanged entity state, when you call the save changes method, nothing is going to happen because the state is not changed. And for detached, these things are not going to happen. Detached means the DB context class not capturing, not tracking the detached entity state. The DB context class only tracking these 4 entity states. See, you can see this is the reason why DB context class is not part here. The DB context class only tracking the entity which is being added, modified, deleted, or unchanged. Added means insert SQL query is going to be generated and executed. Modified means update SQL query. Deleted means delete SQL query. Unchanged means no SQL query is going to be generated. And these things are going to be executed on the database only when you call the save changes method. Clear?
Yes.
Right? Right. Now let us see one example to understand these things, right? So first one is unchanged entity state. Unchanged means what? Now if you have fetched the data and then you have not done any kind of changes, right? So so this is before save changes, right? Before save changes, right? So in this case, you can see I have fetched one entity, right, storing the department table. And if you want to check the state, you have to write this statement context.entry, right? You have to provide the entity, right? So in this case, the entity is first department, and then you can fetch the state of the entity by calling the state property, right? So before save changes is called what is the state of this entity, and after the save changes is called what is the state of the entity. That is what I'm providing. As you can see, once I fetch the department, right? Once I fetch the entity, I have not modified anything. I have not deleted that entity, and I have not insert any new entity into this department collection. So by default, it is going to be in unchanged state, right? So in this case, save changes does not do anything, right? The state before save changes and the state after save changes is going to be unchanged. You can see unchanged. Unchanged means the entity has not been changed, but it is tracked by the context object. Clear? Guys?
Yes.
Right.
Yes.
Right. So unchanged means there is nothing to do. Right. So the next one is attaching the existing entity to the context object. Right. So in this case, you can see I'm creating one existing department. If you go to the department database table, right, then you can see there is a department which ID 1 and the location is Mumbai. So here I'm creating one department, existing department ID 1, name IT BPSR. Where is BPSR? This is going to be Mumbai, right? So I'm creating an existing department, right? And see, in this case, this is not generated by the context object, right? In our previous example, the entity is generated by the context object. But in this case, this entity is not generated by the context object. And if you want this entity to be tracked by the context object, then what you need to do, you need to attach this entity to the context object. And how you are going to attach? By calling the attach method on the entity, right? So context dot department, this is the entity which you can find inside this departments table. Whenever you are going to add, insert, update, delete, you have to use this one, departments table. And if you are performing the operation on the employee database table, you have to use employees, right? So in this case, I'm attaching this existing entity to the department's context object, right? So this is attaching. Once you attach this entity, right, existing entity into the context object, now the context object tracking this existing department. And in this case, you can see this ID name location, right, is already available inside my database table, right? So you can see, this is one of the way to attach. Another way to attach, right, using this one, context dot entry dot state equals to unchanged, right? So by default, you want to make this as unchanged, you can attach like this, or you can attach like this, right? So before state changes, right, and after state changes. So in this case, you can see again, this is going to be shared. So unchanged and unchanged. This is going to be sent. Why I have not changed this one? Because that is going to be modified state. I will show you that separately, right? So this is the unchanged, right? So detached state, as I mentioned, in this case, the entity framework context object will not track that entity, right? So in this case, I have fetched the first department from the departments table, and here you can see I have not called this detached. So at this point of time, the entity framework track this entity state, and here you can see the state is going to be unchanged, right? And here I have marked that state to be detached. I marked that entity to be detached, right? So in this case, the state is going to be detached, even though I am changing this location change, right? As it is in detached state, it is not tracked by the entity framework. So if I am doing this modification, then also whenever I call this changes method, the modification will not take effect in the database. Why? Because once you detach means context object will not track this one now. If the context object is not tracking this one, then even though if you call the save changes method, it will not consider this anymore, because this statement is detached. Detachment, nothing is going to happen when you call the save changes method, right? Now let me run the application. Right. So initially you can see whenever you fetch the data, by default it is in unchanged state, and whenever you detached, right, whenever you change the state to detached, then it is going to be detached and it is going to be detached. Right now, if you go to the departments table, then you will see that the state is not updated. So let's start from departments. Right, so you can see the location is still, it is showing Mumbai, and this location doesn't take any effect because the state is detached, which is not tracked by the entity framework. Clear, guys?
Yes.
Yes.
Right. So for unchanged and detached state, whenever you call the save changes method, nothing is going to be happen in the database, whether you updated some column value or not, right? Unchanged or means nothing is changed, and detached means the changes doesn't make any effect, right? This is the point that you need to remember. Right. Next one is added state. Added state means one, whenever we add any element, right, then the state is going to be added state, right? In this case, so I have created one instance of the department class, right? This is one instance, and then I'm adding that instance to the context object, right? How you are going to add? You need to call the add method on the division type, right? And this db set means db set of department, and on that db set you are calling this add method and you are passing the new department. Now this context object will tracking this entity, and what will be the state of that entity? That state is going to be added state, and whenever in this case you will see the state is going to be added, and whenever you call this step changes method, right, then that department is going to be add inside this department table, and once it add the into the department table, then that state is automatically changed to unchanged state, right? And what statement it is going to generate, right? Let me show you. Okay, open this new trace, connect, and this. So now as it is going to be inserted, right, the data is going to be inserted, then what kind of a SQL statement it should generate? Insert, update, or delete? Anyone guess, guys?
Insert.
Insert SQL statement, right? Let me run this application. Right, so whenever you added, the state is added. Once the data is saved in the database, then the state is changed to unchanged state, right? Now if you go to here, then you can see this is the insert query which is generated by the .NET framework, right? And if you go to the database, and you will see the newly added column with the ID 4. Clear?
Yes.
Right. The next one is modified state, right? Okay, let me show you with one example. And guys, this thing we are going to discuss in detail, right? I'm just showing you the different entity states, right? So again, I'm fetching the first department. I'm printing the state of the department. What is the state? In this case, it is going to print unchanged, right? Then I'm modifying the location property. Once I modified, it should print me the state as modified. And once I call this changes method, then whatever changes we have made, right? And in this case, guys, don't think that it is going to update all the column. Entity framework, this context object tracking each and every column. Whichever column is changed, that column is going to be only updated in the database. Most important point. In this case, don't think that I'm changing location means name column is going to be updated. Only location column is going to be updated, because it is tracking whichever column is updated. I need to update only that particular column, not all the column, right? So in this case, location column I'm changing. So in this case, once you update this entity, right, then the state will be modified. And once you call this save changes method, that whatever modification, right, you have done, one update statement is going to be generated by the context object, right? And that update statement is going to be executed in the database. And once that updation is successful, right, then it will change that state to what state? Unchanged state, right? Okay, let me run this application. Right, so first unchanged, then modified, then unchanged, right? Now if you go to here, right, then you will see that one update statement is there. What update statement? Department set location equals to 0 where ID equals to 1. So it is only updating the location column, right? So this is how and with what value BPS are updated. Now if you go to the database and if you fetch this query, right, then you will see that first column value is updated to BPS are updated. Clear, guys? And
Yes.
so point every time you call the save changes method, the entity state is going to be unchanged. Whenever you retrieve the data from the database, the entity state is going to be unchanged. If you are updating, the entity state is going to be modified, and if you are adding a new entity, then the state is going to be added, right? And detached means it is not going to be tracked by the entity framework. And the last state, right, is going to be your deleted state. And in this case, right, so what will happen once you delete, right? So how to delete? By calling the remove method, right? First department, I'm fetching the first department information. I'm printing the state of the department, right? So okay, let me not delete the first department. I'm going to delete the department whose ID is for this one, which one I have created. I'm going to delete that department. Right before deleting, what is the entity state? It should be unchanged. And I'm removing the element here, right? Department state remove method. Like the add method is there to add the element, remove method is there to remove the element. Right? This department is going to remove from this department's data table. And in this case, once you call the remove method, the state is going to be deleted. And this state deleted means what? It is only deleted in this in memory, right? Not executed on the database. Database, it is still the record is there in the database. But when you call this save changes method, right, then it is going to delete the data from the database, and then it will mark this change as objects, right? Let me run this application. Right? So unchanged, deleted, and detached. Detached means what? Once the record is deleted, is there anything to be captured by the framework? If you delete the record, then what is there? Data is deleted. Now, data is deleted means what? The context object is not going to track that thing anymore. And this is the reason why you can see the state is detached. Before, once you retrieve the data, unchecked. Once you remove the data, deleted. Once you call the save changes method, the state is deleted. Right now, you can go to here and you can check the statement. So delete SQL statement is generated. And if you go to the database, right, you can see the data is deleted, right? So these are the different states, right, that you need to remember. Any question from anyone? What are the different states, how the states are changed, how they are worked?
No.
Right. So there is one important method that you need to understand, that is save changes. What is this method is all about? If the entities are in unchanged state, right? If the entity are in unchanged state, and if you call the same changes method, then what will happen? It will not touch them. If nothing is changed, right? If you just retrieve the entity and you just calling the save changes method, then what kind of statement it is going to generate? It is going to generate insert? No. It is going to update? Did you change any column? No. It is going to generate the delete command? No, because we are not deleting that. That means what? Now, if the entity is in unchanged state, then it will, even though you are calling the save changes method, nothing is going to be happen. And this makes sense. If the entity are in added state, right, then and when you call the save changes method, right, then it is going to generate the insert command, right? And once it generate the insert command, once the insert statement is successfully executed in the database, then the changed is moved from added to unchanged state. Clear? Guys? So once the save changes is done, means the state is already going to be changed to unchanged until and if the delete in the case of added and modified, right? It is moving from unchanged, right? And in the case of a deleted, it is going to change to detached state, right? Clear?
Yes.
Right? The point that you need to remember is entity framework builds and execute the insert, update, delete commands based on the state of an entity when the save changes method is called. It executes insert command for the entities with the added state, execute the update command for the entities with the modified state, execute the delete command for the entities in the deleted state. The context does not track entities in the detached state because entities are not tracked by the context object. If the state is detached, then it is not tracked by the context object. So nothing is going to be happen. Clear, guys? When it is going to generate
Yes.
insert, update, and delete command, and how the state is moved from added to modified, added to unchanged, modified to unchanged, right? If it is in delete state, then it will be moved to detached. And whenever you retrieve the data from the database, by default, it's going to be unchanged state, right? And once you delete the data, it will move to detached state, which is not going to be tracked by the context object. Even you can also manually change of an entity to detached state. And once you change the state to detached, then even though later if you are going to perform some kind of a updation operation, delete operation, right, then nothing is going to be happen when you call the save changes method because it is not being tracked by the context objects. And these things are only going to be happen whenever, right? It is going to be happen only because when the step changes method is called, right? If you are not calling the step changes method, then nothing is going to be happen. If you are removing this element and if you are not calling this step changes method, means what? That means this is not going to delete the data from the database. Clear?
Yes.
Okay. So the last important, not important, the last thing that what we are going to discuss today is what are the different flavors of entity framework, right? So if you are going to develop one application, right, you have three flavors. One is database first approach, one is code first approach, another one is model first approach. In simple sense, we can say that if your database is already exist, and from the database, if you are going to develop the application, then you need to go with the database first approach, right? And when to use database approach, which when we are working with a legacy database, if you are working on a scenario where the database design is done by another team, right? Suppose you are developing one application where the database part is going to be managed by the database team. You do not have any information about the database. Then in that case, they will design the database. And once they will design the database, you can use database first approach to create your model classes. And if you are working on a data-centric application, then you need to go with the database first approach. Code first approach means what? Now, if you want to create the domain classes first, and you want the entity framework should create the related database table, storage procedures, right? Everything based on your domain classes, right? Then you need to go with the code first approach, right? So database first approach means the database is existing first, then entity framework will create the context object and entity classes. And in this case, based on your domain classes and context classes, entity framework will create the database. So when to use this approach, if there is no logic in the database, right? You do not have to do anything in the database. Your database is only for storing the data, no more information, right? So when full control over the code, and there is no auto-generated model and context code, the database will not change manually, right? If you want that database is not going to be changed manually by anyone, right? No indexes is going to be added manually, no table is going to be added manually, right? No trigger is going to be generated, no storage procedure is going to be generated. In the database, right? Then everything you want to manage through your code, then you need to go with this code first approach. Model first approach means in this case, right, you will use the entity framework designer, right? Visual Studio EDMX designer, and based on the Visual Studio designer, right? You need to create the database classes and you need to create the database. I mean, in this case, what will happen? Now, in this case, you do not have the code, you do not have the database. You are using the Visual EDMX designer tool, and using this Visual Studio designer tool, you are creating the model classes and you are creating the database, right? Based on your designer tool, the entity framework will create the model classes, right? And it is also going to create the database tables, right? Design database model using Visual Designer. Using the Visual Designer, you are creating something, and based on that thing, right, it is going to create your entity classes and context object as well as databases. This approach is rarely used. People are following the first and the second approach. So we are going to cover the first and the second approach in detail, right? Right, when we really want to use Visual Entity Designer, right? This is not that important, so we are not going to cover this approach. We are going to keep focus on the first and the second approach. So tomorrow we are going to start database first approach of entity framework. And to give you an idea, so whatever we have discussed as of now, This is nothing but your database first approach. And again, we are going to start from the beginning by taking one real kind example where we are going to use 5-6 tables. We are going to use views. You are going to use storage procedures, right? We are going to use everything from the scratch, right? I'm going to take one real-time example, and using that real-time example, I'm going to explain each and every concept. That's it for today. If anybody having any question, they can ask me now.
In these three approach, which one is better one?
So I'm saying now, nobody is using this model first approach. People are using this database first approach and code first approach. And I have mentioned when database first approach is useful, and when you are working with the legacy database, if you are working on a scenario where the database design is being done by another team, and the application development start only when the database is ready. When we are working with the data-centric application, right? So there is a data-centric application means um, uh, the data is going to be changed frequently. The schema is going to be changed frequently, right? Then in that case, right, schema in the sense you are adding indexes, removing indexes, right? Such kind of things are going to be done in the database side itself. Then in that case, you need to use database first approach. And code first approach means if it is not a data centric application, the database only use is to store the data, nothing else. We are not going to create any kind of indexes, storage procedure, trigger, function. Nothing is going to be created in the database side. Everything you are going to manage from the application code itself, right? There is no separate DBA team to manage the data, right? You are having full control, right? Then in that case, you have to use code first approach, right?
Okay, but within only one team can do database as well as code. So which one is good?
See, basically, again, I'm saying if one team is doing, then again, what you want to do with the database? It's going to be developed fast, and then your application is going to start. Or first of all, your application will start, then the database is going to be developed. Which approach you want to follow?
Okay, first we need to create code. So
Then you need to go with the code first approach. If you first you want to develop the database, then you need to go with the database first approach.
if any modifications I need to do manually in database, so
Then you see again, if you are going to do any modification in the database manually, then you should go with database first approach. You should not go with code first. Code first approach means what? Now you are not going to change the database manually. This is the point I'm mentioning here. If the database will not be changed manually. Clear?
Yes.
That is the thing I'm saying. You do not have to add the database tables manually. You do not need to add the storage procedure indexes, right? Nothing is going to be done in the database side. Then only you need to go with code first approach. Clear, guys? Any question from anyone else? Okay. Okay, that's it. Thank you, guys.
Thank you.
Thank you.
Thank you.